We're looking at Chapter 2, Question 4, which deals with opportunity cost and production possibilities. So we're given a set of data that pertains to a toy maker, and it gives us the various combinations of boats and puzzles that he can produce in an 8-hour day. The first thing we're asked to do in this question is to actually graph his PPF curve given this information. So the way you're going to go about that is you're going to take the data points that are given to you and simply go down to the graph and place the point in the appropriate place. So for point A, he can produce 4 boats per day and 0 puzzles per day. So 4, 0 would be our first point. Point B, he can produce 3 boats per day and 11 puzzles per day. So point B would correspond to 3, 11 on our graph. So let's go ahead and go down and actually graph these points. And to do this, you're going to grab hold of this red plus sign, and we're going to plot point A, which is equivalent to 4 boats and 0 puzzles. So we're going to go down to 4, 0 and leave that point there. Point B is 3 boats, 11 puzzles. So again, we're going to grab this red plus sign and we're going to go to the point 3, 11. Point C is 2 boats and 19 puzzles. So we're going to go to the point 219. Point D is 1 boat and 24 puzzles. So we're going to take this over to 124. And then lastly, point E is 0 boats and 25 puzzles. So this is going to go to the point 025. So we've graphed the PPF curve for this toy maker's industry. Okay, so now we're asked the question, suppose the toy maker is currently using combination D, producing 1 boat per day. What is his opportunity cost of producing a second boat per day? So he's currently at point D producing 1 boat and 24 puzzles. And the question is basically asking, what is the cost if he moves down to point C and produces that additional boat? So he's now producing 2 boats but only 19 puzzles. So the opportunity cost is going to be the difference in the puzzles. So here there were 24, here there are 19, so 24 minus 19 is going to give us 5, and 5 puzzles per day is his opportunity cost in this situation. Now suppose the toy maker is currently using combination C, producing 2 boats per day. What is his opportunity cost of producing a third boat per day? So now they're saying here we are at point C and he's producing 2 boats and 19 puzzles. Well, what if he wanted to move down to point B and produce another boat? So he'd be producing 3 boats and 11 puzzles. So here there were 19 puzzles, here there are 11 puzzles. The difference, 19 minus 11, is your answer. The opportunity cost is 8 puzzles per day. As he increases his production of boats, his opportunity cost of producing 1 more boat decreases, remains constant, or increases. Well, we have seen that it went up from 5 to 8, and if you were to do another point, you would see that it would go up again. So the opportunity cost is increasing. Okay, lastly, we're asked, suppose he buys a new tool that allows him to produce twice as many boats per hour as before, but doesn't affect his ability to produce puzzles. We're supposed to graph this new PPF given this new technology that he has. So the way we're going to do that is, again, we're going to come up to our graph, and our initial point A was 4 boats and 0 puzzles. Well, now he can produce 8 boats, but he still can only produce 0 puzzles. So our first point is going to be 8, 0. Continuing on, point B, doubling the production of boats, he would produce 6 boats and 11 puzzles, because again, the number of puzzles does not change. Point C would be 4 and 19. D would be 2 and 24, and then E would be 0 and 25. So that represents a technology change that affected only one side of the PPF situation, in this case the boats per day, and not puzzles per day.